Everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.
Hello everyone and welcome to our next edition of WeAreDevelopers Live. We are streaming live from Talent Garden, Vienna. My name is Sead and today we are going to have 3 exciting sessions. We will talk about Databricks from Airflow. We will talk about facial recognition with deepface, and we are going to have an interesting real use case scenario about checking supermarket waiting times during the pandemic. A super interesting project by Mickey Lombardi, so stay tuned for that. Before we start, as you saw, we have announced the official date for our in-person WeAreDevelopers World Congress next June. Check it out, worldcongress.dev, and grab your tickets, still on super early bird. So yeah, maybe a nice Christmas gift as well. As always, for today, feel free to be engaged in the chat and the Q&A. After each session, we are going to have a short 5 to 10 minutes Q&A session with the speakers. So take the chance and get some answers for your questions. Always keep in mind, we have a code of conduct. Here's a short video about it. Yeah, with all of that said, I would say let's kick off our first session. It's an honor to announce our first speaker. He holds a master's degree from Karlsruhe Institute of Technology. He is an active member in the open source community. He is a machine learning engineer, works at Innovex in Cologne, and he has co-authored several papers on machine learning in some major journals. And it's a pleasure to welcome Alan on stage.
Yes, thank you to be here.
Hi, how are you doing?
I'm doing good. Thanks. How are you?
Good. Are you joining us from Cologne? Or?
Yeah, today I'm in Cologne. We have great weather today, so happy to be here.
Perfect. That's nice. Pleasure to have you here with us today. Would you like to give us a short preview of what we are going to learn from you today?
Yeah, sure. So this talk today, it's actually based on a client's project that we worked on. So we will get to know Databricks, which is like a technology to basically, or a cloud service to host Spark applications. And we will see how to interact with Airflow. So another framework, another open source framework that is there to actually trigger such Spark jobs or other ETL workflows.
Okay, sounds quite interesting. I would say the stage is yours. Have fun and see you in around 40 minutes for the Q&A session.
Yeah, thank you a lot. So first, maybe one slide on me. So as I said, I'm a machine learning engineer here at Innovex. So I work a lot in the area of data science and data engineering and with the Python data stack. Innovex, we are like a IT solutions company. So we implement IT projects for usually big corporate customers. We have like one area which is application development, then we have IT operations, and then we have data management, which is the department that I'm part of. And if you want to know more about Innovex, the head of data science, Florian Wilhelm, he's also here with us. He will be available in the chat. So you can ask him questions about the company or about data science or anything you like during the talk or after the talk. Yeah, that's it with the slides. So let's directly start with the presentation here. So what is Databricks, first of all? So Databricks is a managed Spark service. And what is Spark? Spark is like a open source application, open source framework that is used by data engineers to create applications that are able to process massive amounts of data by parallelizing the entire data processing onto multiple nodes, onto multiple machines within a cluster. And with Databricks, you have a cloud service that basically creates this cluster for you. So you have the ability to create a cluster with a few clicks and execute some of the execute your Spark workflows. So when you are in Azure or in GCP or in AWS and you open up a Databricks workspace, you can get it, and you get basically this landing page that we see right here. And on the left, we have like a navigation bar. And the first point that I want to show you here, maybe as an introduction, is this compute page, where you can actually create a cluster. So you can here click on create a cluster, give it a name, say what runtime you want to have, which basically means what Python version you will have, what Scala version you will have, and so on. And then you can decide like how big your cluster should be. So if you disable auto-scaling, you can say, okay, I want to have 8 workers that have like, for instance, 16 cores or 32 cores or 64 cores. And you can also, for instance, enable auto-scaling so that depending on the load, you get more or less workers. And if you create such a cluster, you can go here on the Workspace tab and actually work with Jupyter notebooks here. So here is an example. So you would create a cluster, you would attach the notebook to this cluster, and then you can actually write Scala code, which is the language that Spark is written in, but also Java and obviously also Python, which is like the data engineering, data science language. And here is a small example. You can like read a file, you can do some filtering on this file, and then you can write out the results. And this can be done now, for instance, this can be done in an interactive way. So basically, if you are a data scientist, you can work with hundreds of terabytes of data, which is pretty expensive in this case, but it's possible with interactively with a Jupyter notebook in this Databricks workspace. If you're not actually interested in working so interactively, which is like when you have a real data engineering application, you would obviously not use you wouldn't create a cluster here and attach a notebook to it and run a notebook. But what you'd rather do is you would go into this jobs tab. So in this jobs tab, you have the ability to create a job, which basically also comes with a name. It comes with a point of entry. So a point of entry can be a notebook where you have here like your application packaged as a wheel or a jar, and then you're importing it from a notebook and then just like running the main method. Or you can also directly use a jar or a Python wheel and so on. You can define a cluster here. So you would, basically here we would come into the same page as we see before, where we can configure our cluster. And then you have a job. And when you have a job, you can basically run it either now, or you can give it a schedule. So here on the right, we can like click on this page, and we can say, okay, we want to schedule it that this job runs every day, every hour, every minute, and so on and so forth. Another pretty new feature now here in Databricks is that you can actually have multitask job, what they call it. And this is that you don't only have like one notebook and one cluster configuration that you're running, but you can create multiple tasks and make dependencies between them. So here in this case, we have this directed acyclical graph where we see, okay, task 1 and task 2, they both can run in parallel when we trigger this job. And once they both successfully finish, task 3 will run. And this is actually pretty new in Databricks. And it's already a pretty cool feature to kind of make this task orchestration, this orchestration of these workflows in a data engineering application, better than it was before, right? It's already more powerful than just having like one simple schedule. But for us in our clients project where we were working, this was actually not enough. So this is where actually Airflow comes in. So Airflow is a framework to also schedule such tasks, but it's more powerful, right? So why is it more powerful? You can also have these graphs here. We will see it in a second. And you can make different trigger rules, for instance, for this graph. So you can say that task 3 should actually only run when one of these tasks fail, or it should always run, but after these two ones. You can create these tasks also dynamically. So you can say, I have a list of countries, right? And I'm running a data engineering for the data of a given country, right? I'm a big corporation, so I have multiple branches across the world. And I want to dynamically create new tasks for some countries when I'm introducing, for instance, this feature to a new country or something like that. And if we look at Airflow, it comes with a UI, right? This is an open source tool that when you start up the service, you actually get a UI out of the box without actually having written any Python code yet. And when you write your DAGs, they kind of show up here. And then you have like a list of your DAGs, and you can see like how it is scheduled. So this one is scheduled every week for Monday and Wednesday. You can see if how many were successful, how many runs have failed, and you can trigger them manually. If you click now on a given DAG, and then you will see its structure. So there is a tree view that also gives us an overview about how were the runs. So we've seen here on this date, on the 7th of November, we failed, but the other runs were all kind of successful. So they ran through. And here, this is actually the better view to understand the structure of the graph is this view where we kind of see the dependencies between our tasks. Right, so when we go actually on a task, we can also click on it and get some additional information. So we can also go and see the logs. So this one doesn't actually have any logs, but for instance, if we go here on this one in the middle, this branch weekday, this one has a log, and it returns some information that we actually wanted to return also. So you will see this in a second. So going back to this DAG, so how much code do we need actually to write this DAG? And in a very simple case, actually, this is not so much. So here, this is actually the entire code that I need to create this DAG. And most of this is actually this function here, which I will explain in a second. But basically, we are how this entire thing works is that you are basically importing this DAG class, and then you're opening up a context as a DAG, and you give it a DAG ID. This is something that you need to do. This is called dummy DAG. Now you give it a schedule, so which is a cron expression usually, or you can use from Python the time delta, or you can give it a none, which is like no schedule. And then you basically build up with operators these tasks. So we see here, I'm using a dummy operator now for the demonstration, which actually does nothing, but only to show you what I want to do here. Basically here, I'm creating a list of these dummy operators. So I'm iterating over a list of countries. And this is on top here, my list of countries. So by this, I can actually dynamically create an operator that would execute something with this country information on top of it. And this could be hard-coded here as it is right now, but I could also load a config file in here. So pretty dynamic. So this is one really cool feature about Airflow, simply that you have this, you can use the dynamic power of the Python language. Also here we have this branch Python operator. This is a special kind of operator, and it receives a Python callable on top of a task ID, as every operator does. So a Python callable is basically a function, and this function, it has to return another task ID. So here it returns either process mon or process wet, as a Wednesday, which are the task IDs of the tasks below. And this way we can actually say, okay, our job runs every Monday and Wednesday, and but I have different processing for Monday than I have for Wednesday. So depending on what day it should either execute this task or it should execute this task. And then at the end, I have another task that's basically, That's all that has a trigger rule none failed. So if none of the tasks upstream failed, this one would execute. So I could write a success file at the end of my workflow. I can also have other trigger rules, right? So for instance, when something has failed, then it should run, or even though something has failed, right? So it should always run, but at the end of the deck and things like that. So this is just a glance of the features that Airflow actually gives us. And yeah, so the thing is, these dummy operators, they don't do anything, right? So what you actually do when you work with real applications, you don't use dummy operators, but you use operators from service providers, right? So there are services for data engineering, right? There are Postgres databases, there is Kubernetes that you can use, there is Databricks, and all of these, for all of these technologies, there are actually operators built into Airflow that you can use to trigger jobs in these services. And obviously for Databricks, there are Databricks operators that I want to show you next here. So if you go into the official documentation of Airflow, you will find in the providers, under the providers package, the Databricks providers, and they have operators there, which is, for instance, here, the Databricks run now operator. And it comes with a lot of arguments that you don't need to understand here. It's really, confusing maybe in the beginning. But first of all, maybe what this operator does, it gets a job ID from a Databricks workspace and then executes this job. So here we actually see when we go into this jobs tab and create a job, then the workspace will give us a job ID, and we can use this job ID in here to basically trigger this job that is predefined. So, and we can either go over these arguments, or we can give it a JSON. And the reason, or a Python dictionary that is basically called a JSON here, because it exhibits this JSON structure. And the reason for this is actually because this operator under the hood uses an API request to basically trigger the job, and it uses the Databricks run now API. And at the end of the day, this will either way, whether you give it as argument or you give it as a JSON, this will be at the end transformed into a JSON that will be used in the API call to basically trigger the job there. And all of these, by the way, all of these arguments, they can all be given over the JSON. The exception is this Databricks con ID, which is here, which is special, and then obviously all arguments that are inherent to every Databricks operator, right? Or to every Airflow operator, like the task ID, like this trigger rule. So all these things, you would pass them not as a JSON, but always as an argument. Anyway, so this Databricks con ID is also one important thing. So in order to use the API, you would actually need to authorize, right? So in every service, when you want to use it, you can generate a token. You can do this also in Databricks over the workspace. You can generate a token. And in Airflow, there is a connections tab. And this connections tab actually is a secret store, you could call it, in order to save secrets there. So tokens for the API calls. And here we have one that is called Databricks default. And under the Databricks default, this connection, I have like hidden my token that I need to basically do the API call to this specific Databricks workspace. And this value here, it defaults to Databricks default. So when I don't specify it, it's in this connection. But when I work with multiple workspaces, which might be the case in like complex structures in corporations, then you would have different connection IDs for the different workspaces and the respective authorization there. Another operator that I use more often is actually Databricks submit run operator. It does the exact same thing as the run now operator, but it does not assume that a job has been created by you manually or in some other way in this workspace. But what you do, you give it the entire job definition with the operator. So you can say here, yeah, I need a new cluster, and it should have like 2 workers and the Spark version, and this is like the notebook that I want to execute, and so on and so forth. So basically the feature, also the functionality is the same, but you are defining this job in your Databricks, in your Airflow code, or you're taking it from some config file or whatever. But it's not like predefined in the workspace. So that's the major difference between those 2 operators. And it also uses the API, obviously, so this runs submit API. And what I also always find better than looking at like these arguments, I find this pretty confusing, is I actually go and look at this jobs API, right? So when I'm interested in creating this JSON dictionary for the call, I would actually go to the official Databricks documentation and look at the run submit documentation. And here below, I actually see the request structure that I need to pass for this operator so that it can actually trigger my Databricks job at the end. So, and this is actually what Databricks provides us out of the box in a combination with Airflow. And this is already a lot, I think. It's pretty cool. But in our client's project, this was not enough. So when you look at how many different things you can do with the API, so you can create jobs, you can like list jobs, and this is only the jobs API, right? So there is a bigger abstraction here. So we have not only the jobs API, but we have also like clusters API, file system API. We can manage our tokens over the API permissions. So we can do a lot of things over the API, but not with these operators. So what we wanted, for instance, to do is we wanted the ability to write a success file out of Airflow into the file system. Or what we wanted to do is we wanted to create one all-purpose cluster and then execute many small tasks on this all-purpose cluster and then finish it off. Because the way how this jobs call works is that every time you call it, a new cluster gets spins up, then the task gets executed, and then the job is deleted, and the cluster is removed. And then the next task would come in, and then you would again create a cluster. And for big jobs, that's fine. But if you have like many small tasks, you might want to, for instance, create one little bit more expensive all-purpose cluster and then submit these jobs once on it and then finish it off. And to do this, we wanted to do this out of Airflow. So we looked actually on how the operators of Databricks have been implemented so that we can like create our own operators that give us this ability. And this is what I want to show you here next. So we have called it like this generic Databricks operator. And in order to create an own operator in Airflow, what you have to do is you have to import this base operator and then subclass it. And when you subclass it, the one method that you must implement is the execute method, because this is the method that is basically defining the logic whenever a task is triggered. So what did we do here? So we are subclassing this base operator, and then we are creating a constructor. So this is the stuff that comes in when we are defining our DAG, when we are defining these operations. And what we say, okay, we need a request type, an endpoint, and a request body. So all the things that you need to actually make a proper API call, right? And then we have this Databricks con ID that we need. And then one very important thing is that you also allow for keyword arguments so that you can basically instantiate the parent operator, which comes with the task ID, which comes with the trigger rules, which comes with all of these arguments. And here, nothing special happens actually. So we're just like creating these attributes in our class. And then what's interesting is this thing here. So this Databricks hook is something that this Databricks operators use. You can import it also from this providers package from Databricks. And you use this hook in order actually and give it this con ID to actually establish this connection, right? So the hook takes care of retrieving the secret, and then it actually gives us this do API call method. And then when you have this do API call method, we can pass in the attributes and do the API calls, right? And everything else is actually just nice to have, I would say, right? So we are logging here, like how does our request look like? Then we are like doing the request, we are like doing the API call, and then we are logging the response. And that's actually it with respect to this generic Databricks operator. So now, like, how would you use this operator? So for instance, we can have a look at our DBFS API here, and we can have a look at how should we, how can we like create a file, right? So we can look at this put operation, which tells us how to create a file. So we need this endpoint, we need this method here, and then we need this request structure. So we need a path, we need, what content should it have, and whether we should like override or not override the file if it exists. So, and this is actually exactly how we use our operator. So we have this intro code to like create any bag, and then you give it a task ID as any operator needs, and then the request type and the endpoint, and you can look all these things actually up simply from the documentation, and like now create a success file at the end of your workflow in this Databricks file system, right? In the file system of the Databricks workspace. And yeah, here we are creating like an empty file in this path. And one detail maybe, but what I find pretty cool, and pretty cool feature here in Airflow is that we can actually use variables when we pass in these strings. So Airflow has the ability when you to like render Jinja templates to substitute them, and when we do this, this bracket ds bracket, this will actually get substituted for the date for which we are running. So there is also documentation on this. We can look it up, and we can see here are a lot of different variables that come in Airflow, and we can use them basically in the strings that we provide to like substitute the values. So here we can substitute it for the date that we are running for. Right, so this way we can not only create a success file at some specific place, but for each date when we run it at a different place. And the only thing that we need to do in our operator to allow for this is implement this template fields attribute and tell it which argument is templatable. So which argument, where can you substitute these templates? And here it's called request body. So this means that everything that's in here passed as a string gets substituted in this way. Endpoint and request type would not be substituted, only if I would allow for it, but the thing in this context, it doesn't make any sense. So we don't have that here. Yeah, so this is actually pretty much it with respect to like the basics about it. If you're going to like have more complex use cases, for instance, if you want to create a cluster and then submit jobs to it, then things become a little bit more complicated. So for instance, we have also written this create Databricks cluster operator, and it uses already a specific API endpoint and a specific method, but then it does a lot of other stuff, right? So for instance, we want to wait until the cluster is created before our next task starts. So we are like running and asking for the state of the cluster, whether it's like created or pending or running. We can also implement this onKill method. So how should the operator behave if you cancel a task manually? So in this case, we want to delete the cluster then. And once this cluster is created, how can you actually use this Databricks operator in order to submit jobs to this specific cluster? So this is also possible, and something that we really use in our project. And it would be a little much for this talk, but I invite you to like have a look at our blog post. You will find it when you like Google for Airflow and Databricks. And here we are actually explaining also all these details. So we have, besides like some suggestions as a tutorial how you can get started with Airflow if you're not familiar with this framework. You will see how to set it up. You will see this generic Databricks operator, how to create that one, and also we have like these implementations for specific use cases. That's it. So I hope you enjoyed the talk. I hope you could take away something from that. Most importantly, like what's possible. I think this is like what you can take out most of like short talks like that. And yeah, I'm happy to answer some questions if you have. Thanks a lot.
Hey, Alan. Thank you very much for the presentation. Very nice. Just give me a second to look out for some questions. Your colleague Florian was also so nice to answer already a couple of them. For everyone who maybe jumped in later, no worries. So all the sessions are recorded, so you will be able to watch them on demand afterwards. So let me see. There was one question from Igor, and he had a small discussion with Florian as well. He was asking about, do you run Airflow locally? But apparently you are obviously running it on the cloud and using Docker for that, for example. Do you want to add something to that?
Yeah, so for the presentation, I have ran it in local mode. But usually you wouldn't do that, right? So usually you would have it in Docker, then you would deploy to a Kubernetes cluster, depending on what cloud service you are. So for instance, in the GCP, you have, I think it's called Cloud Composer. So this is a managed Airflow service. So this is where you can run it as well. Yeah.
Okay, thank you very much. Then there is a question from Pierre. He's asking, how do you optimize the performance with large data amounts?
Yeah, I mean, this is a very, very big question. So I think you cannot also even answer it generically. So one important thing maybe here to just make clear, because I think sometimes people don't get that right. In Airflow, you're like never processing any data, right? So Airflow, it's actually operated in a more lightweight environment. And in Airflow, you're only having the scheduler that is like looking, okay, what task do I need to trigger? And then this data processing, this happens somewhere else. So in our case, it happens on Databricks on a completely different environment, completely different cluster, totally more beefy machines, more power. And then you would optimize, you would optimize the performance there, basically how you would optimize any Spark application. So this has like not much to do with Airflow or anything. It's like any Spark application. There are methods of optimizing it by looking at the Spark UI, for instance, and looking at bottlenecks there, by increasing the size of the cluster, right? So if you like just throw more money at it, it will run faster until some point. And yeah.
What would you say, like when we talk about optimizing, or what would you say have been some challenges in your project in specifically this part in using Databricks and Airflow?
Well, so for instance, I worked on a project where we are, for instance, also migrating existing applications from on-premise to Databricks. And these applications are simply also in very different states. So it's really, really hard. They are sometimes very, very big, and it's actually hard to get around there. And also, if you like want to optimize something and you work with the Spark UI, you like get like hundreds of tasks that you can have a look at, and you can optimize every one of them. And this is really untraceable as like with a couple of people. So what we were doing there is we were like looking at the bottlenecks, we were looking at what is taking most time and focusing on, for instance, these parts.
Yeah, okay, thank you very much. Chris is asking, is Databricks similar to Data Factory?
No, Airflow is similar to Data Factory. So I haven't worked with Data Factory, so I can't tell you much about it, but I know that Data Factory is like also a orchestration framework, so you can basically use it to trigger Databricks jobs there, as you could use Airflow. But I think Data Factory is a lot more clicky. You use it more in the UI, so it's not really Python code and not so dynamic. But for instance, it's a managed Spark service in Azure. So when you are in the Azure cloud, you can just spin it up and you can use it. And Airflow, on the other hand, I'm not aware of any managed service there. So we use Airflow there and on a own Kubernetes cluster, which comes with all the overhead of managing it on your own, right?
Okay, thank you very much. Nick also had an interesting question in the chat. He's asking, what does your preferred data stack look like, including ETL, and how does it perform at scale? Examples, terabyte processing per day.
Sorry, I didn't get the question completely. So what my
he was asking,
data stack?
What does your preferred data stack look like?
My preferred data stack. I mean, it depends on the use case, I would say. So one is obviously Databricks and Airflow, which is pretty cool, or Spark and Airflow, which I think is very powerful for like this when you are building like data engineering applications, like really products that run like on a continuous basis, and you're not like looking much into it. You're just having your regular monitoring. When you're working like more exploratively, right? So when you're like creating this application, then what I find cool in Databricks is that you can work interactively there as well, and you can test your code right away. Yeah, but this is also when you're already pretty much going into a product. If you're like working as a data scientist, so even the step before having a product, then you would probably use the regular Python data stack, right? So you would work with pandas or maybe with Dask, which is like a scalable pandas, yeah, and NumPy and all these things.
Okay, thank you. Leah has a question. She's asking, how many workers can you have per instance in Databricks?
Per instance, so I mean, I'm not sure if there is a limit, but you can have a lot. Like you can also have like 100 works. I think it's not limited by Databricks. What I know is like in at least in Azure, you have like a quota, and it's defined by your administrator, and he says, okay, you can have like 3,000 cores actively running in parallel. So then you can spin up in this Databricks cluster up to 3,000 CPU cores. But this quota can be increased. So we have also on one project like a quota of 10,000 cores. But if there is some limit from Azure or something like that, I can't really say, but it's pretty big then, at least, right? So yeah, you can have like very big clusters there. And I think it's not limited by Databricks, but by the cloud provider who gives you the machines that you're actually using, right, for the operations at the end.
Okay. Then another question. What would you say would be, let's say, some features or functions that would even make your life easier with Databricks or Airflow? So what maybe doesn't work that well, or what could you imagine that could be better in the future?
Yeah. So I think personally that when you look at the UI of Databricks and you work with it, it's very tailored towards this data scientist workflow, right? So, but it's not really very, very good in respect to like integrating someone who's working on a real data product. So you would usually not develop with notebooks, right? So when you develop an application, you have your PyCharm, your IDE, like whatever IDE you're using, and then you're like packaging this and deploying this, and then you need to test it also, and you want the ability to like deploy to this environment, but not in a productive really way, but in a like semi-productive way, so that you can test your feature that you're working right now on. And I think all of these things they're getting there, but they're not like done really, really well. I think, and they are working on improving that. So, for instance, with respect to this task orchestration, it was like a couple of months ago, you had only this simple scheduler, and then now they introduced this more complex task-based scheduler of the dependencies. And I think Databricks is also seeing these points and like improving upon that. But right now, I think it's pretty much also tailored towards this data science workflow, although it's a very, very powerful data engineering application because it's, it has this optimized version of Spark as well. So Spark is usually running faster on Databricks than on, in its regular open source version. And this is probably why most companies use it. But like the UI and everything could be tailored also more towards developers as well.
Okay, thanks for that. Then one question, maybe there is a small discussion between Jeff and Florian in the chat regarding Python. Jeff is a beginner and starting to learn Python. There is a lot of people out there starting to learn Python, or basically starting to learn programming by learning Python, because it's just that popular nowadays again. How was it for yourself? Like, did you first develop an interest in software engineering? You have your master's degree in computer science, I guess, and you then basically, or let's turn it another way around. Like, did you first develop interest, let's say, in machine learning, and then kind of got a track on Python, or did you first jump into Python and then went to machine learning? And how was it for yourself? And what would you advise to beginners how to start? Because there's so many possibilities how you could start to learn programming, in Python specifically, with all of the different use cases.
Okay, good question. So I mean, I had a study program that at the end of the day required me to also hand in like projects that were programmed. So I had to learn it. It was like also mandatory in a certain way. And I mean, I studied information engineering, which is like very broad. So it's not only machine learning, but it's also like statistics. And so at the end of the day, you have a lot of use cases, not only machine learning that you would need programming for. And I started learning it simply because I was aware that this is a very important skill in whatever I want to do. If I want to be a statistician or I want to be like a machine learning engineer or anything. And so this is why I started. And then I kind of like got into it. So I actually later became more interested in this programming part than actually in the statistic part. So I also learned C++ later because I was interested in like how is it going on a little bit on the low level. Because in C++ you have like crazy methods like of optimizing actually your code that you don't have in Python. And I think one thing comes to another. If you like to like puzzle and like get your head around things and understand like it's like a logical game, right? Then you will, for whatever reason, when you come into programming, it will just like catch you and you will just learn it by yourself, kind of. This is at least how it was for me. So.
Okay, very cool. So I don't see any more questions in the Q&A tool, but maybe if you want to share with us a bit about your personal or about your usual work day. So what types of projects do you work on, and are you looking to increase your teams? Do you look for new colleagues? If yes, how could they apply, and so on?
Sure. So maybe the first part of the question. So my regular work day is like I can come to work. Mostly it's now at home, and I usually have a daily. So there's at least one meeting per day. This is also something that I learned when I came from the university and started working in industries, that the communication actually with other developers and with other stakeholders is a very big part of the job. That I actually wasn't also aware of that much, but I think it's pretty cool, right? So I like to talk with others also about problems. You can learn from them, and you can help them. And then I think, like 60-70% is really like coding. So you have discussed your problem. You have like a project management tool. It's called like Jira, and there you have like the tasks that you like created in your meetings. And then you kind of pick up your task, and then you can just start working on it and code on it, and ask people about their opinion on it. So they will review your code before it gets like merged into the main code base. So this is about how like my job looks like. And of course, we are like constantly growing as a company. So we have like a lot of projects where we need good people for. And if you're interested in, we have like Florian here, so you can. You could text them in the chat. You can also text them probably outside of the chat, also via his email. You can text me. We obviously on innovex.de we have our career landing page where our jobs are written out, and you can have a look at them. So we are not only having data jobs, right? So we have also application development. We have IT operations, which is the entire part about like, okay, I want to deploy a Databricks workspace, or I want to deploy an Airflow, right? This is the operations, the IT operations part of it. And we obviously have a lot of data engineering and data science projects and need people there.
Okay, that sounds cool. Alan, that was a very nice discussion. We have been a wonderful speaker and a wonderful guest, so thank you so much. I hope the weather in Cologne stays in good condition, and I also hope to see you soon again at another event, maybe in the future. That said, I would like to say thank you again, and see you next time again.
Yeah, thank you. I had a lot of fun being here, and thanks for this opportunity to talk as well. Thanks.
Thanks, bye, and thanks also to Florian for being actively in the chat and helping people to get some answers. So we are going into a very short break, 15 minutes until our next session about face recognition. Super interesting, so stay tuned, grab a cup of coffee or tea or whatever, and see you in 15 minutes again.
When you're building an application, there's a lot of pressure to keep security vulnerabilities out of your code. But no matter how skilled you are, between your own code, dependencies, and configurations, you can't catch them all on your own. But that's why Sneak's here. We're the secure development platform that can extend the security reach of every developer. With Sneak, you don't have to handle security vulnerabilities on your own. Sneak. Develop fast. Stay secure.
Hello and welcome back to our next session. It's an honor to announce our next speaker. He holds a master's degree in computer science from Galatasaray University from 2011. He's a software engineer at WeAreDevelopers Technology and a true expert when it comes to face recognition and coding with Python. So please welcome on stage, Shefik. Hi, nice to meet you.
Hello, it's a pleasure to meet you.
Shefik, before we start, would you like to give us a short preview of what we are going to learn from you today?
I'm going to talk about deep face facial recognition library today because I'm the main creator of the library and I'm still maintaining it. And the talk is going to be about unboxing the deep face, and because it handles a lot of things in the background. And you actually don't know what's going on in the background, but we are going to talk about the logic and math behind the library.
Okay, that sounds super interesting. I would say the stage is yours, and we see each other again after the talk of the Q&A.
Okay, I'm going to present my presentation. Can you see my screen, by the way? Hello, everybody. Thanks for coming. I just want to thank first WeAreDevelopers organizers for inviting me, and also my employer, WeAreDevelopers Technology, for supporting me to come here and talk. And today, as mentioned, I'm going to talk about deep facial recognition library and unbox it to understand the math and logic behind it. But before that, let me introduce myself first. This is Shefik, and currently I'm a software engineer at WeAreDevelopers Technology. I'm also a contributor of many open source projects, and in particular, I'm the creator of DeepFace. I'm still maintaining it. It's highly adopted by the open source community. Today, it has 2,000 plus stars on GitHub and 250,000 plus installations on Python package index PyPy. I have a personal blog, cefix.com. I write here technical tutorials, mostly related to programming and technology. Also, I'm creating online content on YouTube. You can access my channel with my full name. Finally, you can find me on Twitter with my surname. If you mention me anything about this speech, and I will promise I'm going to answer it. And let's start. We are going to talk about deep face facial recognition library, and it's a Python package actually, and it offers out-of-the-box functionalities and features for facial recognition. So you actually don't even need to acquire in-depth knowledge about the processes behind the library, and you are able to run facial recognition with a few lines of code. It's fully open sourced and it's also licensed under MIT license. In other words, you are completely free to use it for both personal and commercial purposes. It's also published on Python package index, or shortly PyPy, with its release history. As mentioned, it's available on Python package index, and the easiest way to install the package is to run the pip install deepface command. Once you install the package, you are able to import it and use its functionalities. And verification is a common task in deepface. It expects a face pair as exact image paths. For example, in this code snippet, we are going to verify image1.jpg and image2.jpg. This pair is same person, or these are different persons. Then it's going to return the decision that they are same person or different persons in the verified case. For example, in this example, it returns true. This means this image pair is same person. And it also returns some additional fields, such as the distance value, threshold value. We are going to mention what those cases mean. Deepface wraps many state-of-the-art models for both face recognition and face detection. You can switch among its face recognition model and face detector portfolio with an argument. All functions and its interface except optional model name and detector backend arguments. The default face recognition model is VGG face, and the default face detector is OpenCV. I mean that if you don't mention anything, then Deepface will use VGG face and OpenCV pair, but you can switch among FaceNet face recognition module and Retina face detector, for example. If you have image pair and you want to learn they are same person or different persons, then this is going to be face verification, and its time complexity is O1 in the beacon notation. But face recognition studies mention this task as face recognition, but it's not face recognition, it's a face verification. If you want to look for an identity in a database, then that's going to be a face recognition, and it requires to run face verification task many times. That's why the time complexity is going to be O(n) in the beacon notation, where n is the number of instances in your database. Notice that O(n) time complexity is problematic when n becomes really big, millions or billions. As mentioned, face recognition requires to run face verification many times, but luckily you don't have to call a face verification function in a for loop manually. Deepface can do it in the background as well. You should mention the identity you are looking for in the image path argument here, and you should set the database path to your facial database. For example, here users slash Shefik slash db is a folder, and it contains many facial photos. And we are going to look for the identity of target.jpg in this code snippet. Then this is going to return the identities it found. For example, I fed the image one.jpg as target, and it returns the following 3 images as similar person, same person. In addition to its face recognition module, Deepface has a facial attribute analyze module as well. It basically analyzes the apparent age, gender, emotion, and race or ethnicity. In this way, we plan to fight the biased datasets in the training of facial recognition models. Also, we intend to decrease the search space with demography in facial recognition tasks. Here, age prediction task has plus or minus 4 years error score, and gender prediction model has 97% accuracy. And its precision and scores are very close to 79% as well. As mentioned, Deepface offers an out-of-the-box functionalities for facial recognition. From now on, we are going to mention the tasks it's doing in the background. Deepface applies all required stages of a modern facial recognition pipeline, and there are 5 common stages of a modern face recognition pipeline. These are 1. Detection, 2nd, alignment, 3rd, normalization, representation, and verification. We are going to visit those stations one by one in this talk, and let's start with the first station, face detection. We find the facial area in a picture in the detection stage. Deepface wraps many cutting-edge face detectors. These are OpenCV, SSD, MTCNN, DLIP, and Retina Face. Here, if your task requires high confidence, then you should consider to use retina phase or MTCNN because they are very powerful models, but they are slow. On the other hand, if your task requires high speed, I mean that speed is more important than the confidence score, then you should consider to use OpenCV or SSD because their detection performance is okay, but they are very fast face detectors. We are going to mention that we will feed pre-processed images to a deep neural network model. And deep neural network models expect standard size inputs. So resizing is required when you detect a face in an image. For instance, if you resize a rectangle image to a squared one, then it's going to be deformed. That's why here we are adding some black pixels to avoid deformation. And those are the results of those face detectors wrapped in deep face. Nowadays, we have very powerful face detectors, and you are seeing the result of retina face model in this illustration. It's a deep learning based model, and its robustness comes from here. Its detection performance in the craft is amazing, and it can find even the ones in the backgrounds. The detector also finds some facial landmarks such as eye positions, nose positions, or mouth positions. We can use these landmarks in the following stages, such as alignment. We will mention it. The second stage is alignment, and let's visit this station. Experiments show that just alignment increases the face recognition accuracy more than 1%. This score might not seem to offer a major contribution, but we already have models with human level accuracy, so we can just make a difference with those little touches. We need eye positions to align a picture. Detectors wrapped in deep face can find facial landmarks as mentioned before. So we will rotate the image until the both eye coordinates becomes horizontal. The third stage is normalization. And let's visit this station now. Face detectors detect faces in a rectangle area, and it might store some noise information. We can also find the several facial landmarks of a face. For example, the ellipse returns the 68 facial landmarks mentioned in the middle image. In this way, we can get rid of the noise information in a facial image, and we can extract the just facial information in the image as shown in this illustration. The next stage is representation, and this station is very important because we are using deep neural networks here, but the usage is a little bit different than the regular neural networks. That's why we are going to spend a lot of time in the station, and let's visit it. Neural networks, and especially convolutional neural networks, dominate computer vision studies recently because CNNs are very good at detecting some patterns in the visual data. So facial recognition models are mainly based on convolutional neural networks. Suppose that you have a dataset consisting of 100 identities, and each identity might have more than one facial photo. We will build a CNN model, and its output layer should have 100 nodes because our facial database has 100 identities. Then we will fit the images of identities one by one. For example, here we are feeding the images of Angelina Jolie, and its corresponding output should be one. Angelina Jolie is one, and the other output nodes are 0 in this case. In that way, neural network will tune its weights based on the input and output pairs. Then we are going to fit the facial photos of different identities, and now we are feeding the facial images of Jennifer Aniston, and we set the corresponding out to 1 and others to 0. Then neural networks continue to tune its weights. And finally, I'm feeding the images of Scarlett Johansson, and its corresponding output is going to be 1, and the others will be 0. In that way, neural networks continue to tune its weights. We define the facial recognition as a regular classification task from now on, and we already know that convolutional neural networks are very good at classification, and we can guess this approach is going to work. But what if a new person would come into our database? For example, Katy Perry here doesn't appear in the identities of our facial database. Here we can add a new node to corresponding identity, and the output node is going to be 101. This is not going to work because our model structure is changed. That's not a good thing, and our model will become more complex. It's going to become complexer when a new member joins in this approach, and we need to retrain the model always when a new member comes. We won't have a centralized model. Each company or each institution should train its own model and store it. We don't have a generalized model. The question is that what if the new model underperforms? We really need something different. As an alternative approach, we won't add a new node to the output layer. I mean that there is no corresponding node for the Katy Perry in the output layer in the right side. Once you fit the facial images of Katy Perry, then the network will produce the output for Katy Perry anyway, and we will call this output probabilities as vector embeddings in the rest of the study, and we will use those embeddings in the facial recognition tasks. So we have a generalized model in that way, and we don't need to retrain the model anymore when a new member comes, and we will train it once and use it always, and the complexity of the model is always same. Here, as mentioned, neural networks models, facial recognition models are actually based on convolutional neural networks, and those are the supported models within DeepFace, and they are all CNN models actually. It supports 7 cutting-edge facial recognition models. Those are VGG Face. This is developed by the researchers of the Oxford University. For example, FaceNet is developed by the Google researchers. DeepFace is developed by the Facebook researchers, and ArcFace is the newest one among those models. These are actually deep neural networks models with different structures, and notice that those models already reached and passed the human level accuracy. As I remember, human beings have 97.5% accuracy in the facial recognition tasks, but those models passed that level accuracy. And the final stage is verification. It requires to run representation stage before, and let's visit this station. We are going to talk about the distance, but before that, I want to read a poem of a famous Turkish poet, Can Yücel. We have been talking about very confusing concepts, and this might help us to recharge our batteries. The name of the poem is The Longest Distance, because we are going to mention the distance. and the rest of the slides. The longest distance is not to Africa or China or India, not to the planets or the stars that sparkle in the night. The longest distance is between two minds that don't understand each other. Luckily, we do understand each other. Let's turn back to the distance concept. We represent facial images as vectors in the previous representation stage. And here we expect that vector embeddings of same person should be more similar than the embeddings of different persons. We can formulate the similarity with the high school math actually. Please remember the Euclidean distance formula. This is not the only way, but it's very easy. That's why I mentioned that formula. We need to find the sum of the square difference of dimensions to calculate the square distance. This is an example for three-dimensional space, and facial recognition models actually creates vectors with hundreds or thousands of dimensions, but this formula is still still applicable for multidimensional vectors, and we are going to use this formula as is. So we have the distance values between vectors and corresponding facial images. How to determine a face pair is same person or different persons? This graph shows the distance distribution for both same person and different persons. As seen, the distance values for same person seem to be less than the distance values for different persons. Here, we can determine a threshold value based on the distribution graph. For instance, we will verify pairs if the distance value is less than the threshold value for here. And here you are seeing the distance values between the image pairs of Emilia Clarke and Lena Headey. If we set the threshold to 4.16, then we can verify all instances correctly. Even though the daily appearance of Emilia Clarke is and her role in the Game of Thrones don't look like each other, our model can verify them. By the way, these results are retrieved with the Euclidean distance and arc face recognition model. And let's adapt deep face for a more challenging problem. Let's run it on a big data and require highly scalability. Have you ever wondered how Google run reverse image search algorithm? We know that they are using a convolutional neural networks model to convert images to embeddings. Then it will return similar images with close embeddings. For example, I fit the image on the left side to the Google reverse search, and it returns the items in the right side. And it really returns the images of Angelina Jolie here. The question is that Google indexed 100 billions of images, and how can it perform this query in seconds or milliseconds? Is it related to the hardware they have? Similarly, Facebook image tag module applies same procedures. When an image added, even if the adder is not your connection, its face recognition module can find you in seconds. And as I guess, Facebook has billions of users and probably 100 billions of images. How can Facebook perform this query in milliseconds? Is it related to the hardware Facebook has? Here, a well-known Turkish photographer mentioned that if the best camera had taken the best photograph, then the one would be the best novelist who has the best typewriter. Similarly, query performing times should not be related to the hardware those tech giants have. Firstly, we can group the items in our database with demographic information because DeepFace already analyzes age, gender, emotion, and race, ethnicity demographic informations. We can store those information for items in our database, and then you can decrease your search space when you are going to search an identity. That's a good way to search, but it's not enough. You will be able to know the demographic information of one you are looking for, but the search space is still very large. Here, Google and Facebook are running approximate nearest neighbor algorithm instead of k nearest neighbor algorithm. That's why the time complexity becomes really small when it's compared to the value of n, because the complexity of KNN algorithm is ON, but time complexity of approximate nearest neighbor algorithm is very small than the value of n. Spotify uses that algorithm to recommend playlists. Currently, we have Spotify Annoy. That's the acronym of approximate nearest neighbor, OYE. We also have Facebook Face. That's the acronym of Facebook AI Similarity Search. And the MSLib, it's the acronym of Non-Metric Space Library. Besides Elasticsearch wraps NMSLib as well, and Elasticsearch comes with high scalability as well. We also have Milvus and Pinecone vector databases as well. Those frameworks are open sourced to run approximate nearest neighbor algorithm, and this algorithm has a very small time complexity, but it applies a heuristic approach. That's why they might miss some vectors, as seen this illustration. It might miss the close ones sometimes. So you can use the DeepFace to extract facial embeddings as well. You pass the exact path of an image, then it's going to return a multi-dimensional vector, and you can store the output vector as is in the technologies we are going to mention. For instance, if you fit this image to a DeepFace, then it's going to return a vector with 2622 dimensions. It's the output size of VGG face model wrapped in DeepFace. You can think output as an one-dimensional array with 2622 items here. And we are going to discuss the recommended tech stack for face recognition and face verification perspectives. If you are going to run face verification, then the time complexity is going to be O1. Please consider this use case. We will log in to a mobile application of a bank, and bank should store facial embeddings of its all customers in a data store. You can firstly store the vector embeddings in a relational database. However, vectors or arrays are not valid data types for relational databases, and you should store each dimension or each item of an array in a column or row in a relational database. As a better way, you can store your embeddings in a key-value stores such as Redis or Cassandra. Relational databases are good at storing and collecting relational data, but here we need just an embedding of a customer. In this case, relational databases cannot work as fast as key-value stores. Besides, you can store vector in a key-value store as is. I mean that there is a valid array type in those key-value stores. You don't have to expose its dimensions to columns or rows. Notice that face verification is a subset of face recognition, so you can use the same tech stack of face verification in face recognition studies as well. But when data size becomes big, those are not going to work. And if your task requires high confidence, I mean that, for example, if you are going to search a guilty in a citizen database, you should use k-nearest neighbor algorithm because, as mentioned, approximate nearest neighbor might miss some identities. Here, NoSQL technologies such as Hadoop, Hive, Spark are good at running KNN. On the other hand, if your task requires high speed instead of confidence, then you should consider to use approximate nearest neighbor algorithms such as reverse image search case. And those are the common approximate nearest neighbor algorithms we have. To sum up, DeepFace is a lightweight framework, and you can use any functionality with a single line of code. And you don't even need to acquire in-depth knowledge about processes behind it. Secondly, it's easy to install and run. Some of the popular facial recognition libraries require core C and C++ dependencies that makes them hard to install and initialize and compile. You might have some troubles in the compile step. However, DeepFace is mainly based on TensorFlow, and that makes it very easy to install and run. Thirdly, DeepFace currently wraps many state-of-the-art face recognition models and face detectors. The list of supported models and detectors has been expanding since its first commit, and it will continue to grow over the future. Fourthly, DeepFace is licensed under the MIT license, and you are completely free to use it for both personal and commercial purposes. Besides, it's fully open sourced, and you can customize the library based on your requirement as well. Moreover, the DeepFace has a growing community. It's highly adopted by the community, as mentioned before. Currently, there are tens of contributors, thousands of stars, and hundreds of thousands of installations. Even if you face an issue, you will likely find the solution in the discussion forums such as Stack Overflow. And finally, DeepFace is a language-independent package. Even though its core functionalities are written in Python, it serves as an API as well. In that way, you can run facial recognition and facial attribute analysis functionalities from mobile or web clients too. So, a review of modern face recognition pipeline has been done in this talk, and then the description of developed lightweight DeepFace framework has been made. And DeepFace makes facial recognition very easy and simple. You are able to run facial recognition with a few lines of code. We then mentioned how to use DeepFace with some accelerating technologies to make it highly scalable. I thank you all for watching. If you have any questions, I will be happy to answer. That's out of my talk.
Hey, Shefik, thank you very much. Super interesting and a very nice overview. For everyone, I already had a look at the GitHub repositories. It's very well documented. So I can only advise and recommend to have a look at it as well if you're interested. So Shefik, thanks again. We have a lot of questions. If you have a couple of minutes to stay with us, then
I will be happy to answer them.
Perfect. Let's see. I need to scroll a bit through. Matthias has an interesting question. How do you measure emotions? Do you rely on facial landmarks, FACS, or similar? And are the accuracy rates comparable to commercial products like Noldus face reader?
We measure the emotion scores with regular precision recall scores, we actually trained the emotion model with FER-2013 dataset. That dataset has training set and test set as well, and we test the result of the emotion model with its test set. And we actually published the scores for each emotion in the repo, but I don't remember each score right now. One can visit the repo and can learn that scores with the readme of the file, readme of the repo.
Okay, perfect. Then Giorgio has a very interesting question. Could this framework be modified to also work with 3D sensors and not only images?
Deepface actually handles video streaming as well, but as I mentioned, it's open sourced and licensed under MIT. Anyone can customize the library based on their requirements.
Okay, thanks. So Giorgio, if you are going to work on that as well, then feel free to recontribute to the community. But nice idea. Then there is a interesting question from Luis. How do you find out the perfect threshold value?
With the positive examples, I mean that I fit face pairs with same person, and I fit face pairs with different persons. Then I have slides for that. Then we have a distribution graph for same persons and different persons. We then feed that scores to decision tree algorithm C4.5, and it finds the best threshold to determine. In that way, we tuned the thresholds.
Okay, thank you. Then Mirko has a question. He's saying there are many images on the web that have been generated by AI and are not real. Is there a tool or way to say that the image is from a real person or AI generated?
It's not related to deepface, by the way. Deepface is a facial recognition library, and I think the question is related to deepfake. It's not
obviously, but maybe you heard about some, or you had some. Maybe you have an idea of how this could be solved, or if it is solvable at all.
That's total different topic and area. I don't have any experience about the gun images.
Yeah. Okay. Fair enough. Then Christopher, how to make sure that there is no bias in face recognition? I would maybe rephrase it a bit. So obviously you need a lot of training data as well, right? So if you are basically, I would say that maybe you need like enough training data from people with different backgrounds and so on and so on, or maybe what's your take on that?
For example, labeled face in the wild. It's a de facto database, a de facto data set for facial recognition studies, and all facial recognition researchers test their models on that data set. And we actually use pre-trained models in deepface. I mean that Google FaceNet researchers trained their own model and publish it in the internet. And I actually wrapped that model. I mean that I didn't train any facial recognition model in deepface. I found it and converted to the TensorFlow. That's why how we know that we can read the research papers of those facial recognition models and check its results on labeled face in the wild dataset. That's the way.
Okay, perfect. Thank you. Then next question from Costas. Is there an application on faces that have been malformed or altered for some reason, for example, medical, cosmetic, and so on?
could you repeat it? Because
The question is there an application on faces that have been malformed, altered for some reason? So Kostas, if you could specify the question more, that would be fine. But I can imagine that he's asking if you could use this tool also for let's say images or faces that are not that have been malformed, let's say from an accident or for medical reasons, surgery or cosmetics and so on. Does it still work?
I don't know, to be honest. We have to check it. Let's skip this question because I don't know the answer.
Okay, fair enough. Then maybe another question. Maria is asking: is there a minimum resolution needed for images? So that it
I
works
didn't check
properly.
it, but I work with high
Resolution.
high resolution images.
Okay, so
But
obviously, if the
but labeled face in the white, it's a low resolution data set. That's why its score becomes higher with the high resolution. But there's no precondition.
Okay, but obviously, if the image has a higher resolution, it should work better, right? So
yes.
Okay, perfect. Okay, Kostas has specified his question. He's saying he's referring to the verification problem. For example, compare Michael Jackson before and after the cosmetic surgery, if there was one.
I think it's not going to work, but I tested deep face on specifically the in my slides the Emilia Clarke in Game of Thrones and Emilia Clarke in real life. This pair they don't look like each other, but deep face can guess they are same person.
Okay, so also obviously depends on the change, on the level of change, right?
Yes.
So if it's just a bit cosmetics, it might work, but if it's a totally different face, obviously it wouldn't work.
Absolutely.
Okay, perfect. So Kostas, I hope this answers your question. And then another question: do you know of a Nextcloud integration to analyze your own photos?
This is going to be integrated to the cloud. That's the question.
A Nextcloud integration for someone to analyze his own or her own photos.
What's Nextcloud?
And sort them by people. To be honest, I don't know. So for that, like, if you want to specify the question, just go ahead. Then let me see if we have other questions. Interesting one. I had this before at some other session. Igor is asking, what is the solution to identify twins?
Oh, I didn't check it, but I think it will fail.
Yeah.
Because that models trained with face pairs and twins are looking to each other.
Okay, but we could give it a try. I remember another session where we touched that topic. I'm not sure who was the speaker. I can look it up. And they said that there might be solutions out there. You just need really a lot of data and a lot of different images from these persons, because there's always some very small details that could be different, and then you kind of could differentiate between twins. But a good question. Thanks, Igor.
We have to test it.
Yeah, that would be interesting. Okay, the Nextcloud is a self-hosted file cloud. It's similar like own cloud, or let's say Dropbox for self-hosted Dropbox. Obviously, it is referring if you could use deep face on your local machine, and then, for example, sort your own photos by people or something. But I mean, to shorten this up, I would say as the as Deepface anyway is open source and you can find it on GitHub, then it would be a very interesting project to try it out and to let the community know how it worked. So I'm pretty sure it could work like just on your local machine and try it out. Okay, I think that have been all the questions so far. Just a second to make sure I didn't miss anything. No, that was everything. Shafik, it was a wonderful overview, and I think it's a really cool project. Are you using it a lot also for your customers or in the company, or is it just a personal project that you're
That's a personal project. That's why it's totally free. That's my personal project.
And how did you get the idea? So did you wanted to solve something specific, or you just saw that there is maybe a need out there in the
As
community?
mentioned, there are tons of facial recognition models in the internet, but they are all written with Jupyter notebooks, and you have to run those notebooks. And even if you know how to run it, you have to spend a lot of time to initialize it. That disturbs me. I want to make it a package, and people should use those models with a line of code.
Yeah, that's a good thing.
Because I like tooling. That's why I found a lot of stuff, existing stuff, and make it package it.
That's a good thing. So thank you for the project and thank you for being our guest. You have been a wonderful guest today. So I hope to see you soon again. Wish you a nice rest of the day. Greetings to Istanbul, and see you again in the future. Bye.
Thank you very much. Have a good day, and goodbye.
So we are going into another very short break, just 13 minutes, and then we have another session. We are going to see a crowdsourced map to detect waiting times in supermarkets, which obviously is a very useful tool to in times of a pandemic, presented by Miki Lombardi. Very nice speaker, so stay tuned and see you again in 10 minutes.
Everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.
Hello, everyone, and welcome back to our last session of the Python Day. It's an honor to announce our next speaker, Mickey Lombardi. He's a co-founder of Schrödinger's Hat. He's a full-stack software engineer at Growens. He likes pizza, Raspberry Sport, and Kernel Panic. And yeah, please welcome him on stage.
Hi, everyone.
Hi, Mickey. You're joining us from Italy, right?
Yeah, from Florence.
Florence, very nice, very nice. Tell me what are you going to show us today?
Yeah, it's a case study of my side project back in 2020 with the global lockdown, and is about a map that it was used for showing the supermarket waiting times to get your food and beverage during the lockdown.
Yeah, has it been used a lot? I think yes.
Yeah, surprisingly. But at the beginning, it was just for personal use, just for myself, my family, and my friends. But then randomly, it went viral somehow.
Okay, that's a good thing. I would say the stage is yours. Have fun and see you in half an hour, 40 minutes again for the Q&A.
Okay, thank you. So, hi everyone. Thank you for joining into this session. As I said before, in this speech, I'm gonna show you a case studies, and I'm gonna talk you about all the projects from the beginning to with also some analysis on the data and the cost to give you some conclusion and some inspiration to do so in the future. So the title is the name of the project, a crowdsourced map for checking supermarket wait times worldwide. It's a 2020 project, and it was used for helping people during the COVID-19 global lockdown to go outside and be in outside less time possible, to go to your grocery shop, to the pharmacy, parapharmacies, and other places. So let's start. First of all, who am I? I'm Mickey. I'm from Florence. I'm actually a full stack engineer at Growens, and also the co-founder of the Schrödinger Hat podcast. It's a podcast. It's a community, an Italian community. It's an open source organization. We do coding and all that stuff. As Vincent said, I'm in love with Python, but especially with pizza, as I am Italian. You can find me everywhere as the join, or you can go on my personal website at michilombardi.com, and you can find all the links except for TikTok. I divided this talk in four chapters, in four main areas. Of course, I'm gonna get you into this project, so I'm gonna take you with the hand and go for an overview. Then we're gonna have a look through the architecture of the project, the cloud environment, the local environment, and also have a look at the APIs and how I used Redis for Python. And at the end of the talk, I'm gonna speak here about the cost that I took for this project, because it's very, I think it's very funny to see, but it's also very useful for many of you that maybe want to try something with a low budget project, and give you some conclusion. So, as you may know, in 2020, COVID-19 hit everyone. It went from China to Italy as the first European country that was hit by the virus. And at the beginning, no one knows what to do for sure. And everyone just panic and get into the supermarket just to find out that, oh my God, there are so many people at the supermarket waiting in line to find that the store was empty. And this situation, I thought it was just for Italy, but then after maybe in April 2020, the situation was like that, also in the global situation. So the globe went into the global lockdown, and everyone was just locking into their houses. And also going outside to take a walk, it was almost impossible, at least here in Italy. And everyone, of course, just wanted to go outside, and the only reason that you could go outside, it was just to go out to the grocery store, or the supermarket. And of course, this gift is pretty real, because once you get to the supermarket or grocery store, you find out that you need to wait in line without a mask, because it was the beginning of the pandemic, just for maybe 1 hour or 1 hour and a half with other people with no social distance. So it was pretty high risk of contagious. So what was the issue? Well, the issue in the day following the global lockdown was that all the supermarket, all the pharmacy were attacked by people in search for basic goods and necessities. And of course, it's not the ideal when you need to manage all those resources. And immediately, the supermarket were incapable of manage those people and also manage the resources that they had into the superstore. So the context was, of course, an emergency, especially a medical emergency, but also for food and beverage for people that maybe for family, for old people, or with disabilities or something else, not just for young or family people. And also because the longer stay into unventilated environments, such as the grocery store, the superstore, the supermarket, it's more likely that you could contract the virus, because we didn't wear a mask, we didn't do the social distance, and so on. In this talk, I'm gonna speak about my project, and you can find all the code archived in my GitHub profile. This is the link, the hood. And you can find all the code from backend with Python, and also the front end written in plain JavaScript. It's pretty simple. So the idea, it started out that after a couple of times that I went to the grocery store, I found out that maybe I can find a way to tracking down the amount of people and the amount of time that I need to wait before entering the store. Somehow how it works like for traffic with the Google APIs. And the goal was to represent those data through a map, because I want to get into my local superstore or the pharmacy superstore or my local pharmacy, or also for my friends, the local store in another city, and so on. So the map, it was the perfect choice to represent the data, with a point of interest, with all the places that we needed to tracking down, and to see how many people are in line. So I needed to find out if there were a solution to take those data from Google or from other sources. And I found out that there were a possibility for like scraping some data from the internet, and I did. But the perfect choice was crowdsourcing, because giving a tool to all the people that were in line, the people can give you a feedback, and that feedback is for sure 100% better than the API, because the API is not real time. The people are in the line, so they can give you a good feedback. And of course, if you tracking down, you make an average, you could have a good data and a good results. These are screenshots from what it was the map. Now it's no longer available. The map was online from April 2020 to June 2020, where the global lockdown was in a better situation, and everyone started to be more responsible. Also, with all the government say that we needed to wear a mask, we needed to keep the social distance, and so on. The map worked like a usual map. So you could search for an address, search for a city. You could search for a place name or a place address. You could also give the feedback for that place or that address, so we can gather all the information and update the map. So the next user can have the right data and the right time. And this is pretty much what was doing the map back in the 2020. Of course, it was at the beginning for personal use, and also for my friends that were living in other parts of Florence. And we got different store, a different pharmacy. Also in sites, they were different. And so I needed to find out a good method to give them this map, and I put on my Raspberry, and I'll talk to you later about that. And so they connected through my Raspberry via port forwarding from my network, and they search out all the place, all the address, and randomly it went viral, the map. And these are some data. They are just data collected anonymously from analytics. And from late March 2020, I started out for personal use because in Italy, our lockdown started in 1st of March, maybe. So in late March, I was already doing some tests for personal use. And from April, I just made it public for anyone that needed a tool to check the supermarket waiting times or other place. And these are all the data. So the technology that I used, it was, of course, Python, Mowigi, Nginx for the backend part, also with Flask and Redis, of course. Meanwhile, for the front-end part, I used a plain JavaScript application. I started for my personal template. It's pretty simple, the front-end side. And I made also a progressive web app, so everyone could use the application from their mobile device in a very easy way. And of course, I mentioned Raspberry Pi, that is pretty my love now, because at the beginning, I hosted everything, the front end and the back end, onto the Raspberry Pi. It's a freebie model, because in 2020, the 4 model was released maybe in late 2020 or mid, I don't remember. And I used the port forwarding and dynamic DNS for personal use and for beta testing with my friends. And yes, the load average of Raspberry was pretty high, but it maintained a very good performance through all the maybe first month. Considering also that we were using Redis in the same instance of Nginx, of the backend and also the front end. So a lot of traffic and a lot of computing. And of course, for beta tester, I need to specify, friends, moms, friend of a friend, grandmoms, uncles, and so on, because I used my friends for helping them out, but also give me some feedback because I need to improve it. And so from local with Raspberry, it went worldwide in about 10 days properly. So I needed to find out that maybe the dynamic DNS into my house, into the Raspberry, wasn't the ideal. So I changed it, and I changed it into a cloud environment, pretty simple. And I used the virtual private server from OVH, OVH Cloud, because first of all, they were cheap, probably the cheapest VPS that I found out on the internet, also better than Linode. And it was 2 gigabytes of RAM plus 30 gigabytes of ROM. It was pretty good with maybe an Intel dual core on the backend. And also, I had also 3 VPS from DigitalOcean, dislocated in the geographical region with more traffic, and from the US in New York, and UK and San Francisco, just to simulate a CDN. So why I decided to go in cloud? Well, first of all, Raspberry is really great for managing couple of contemporary user, but after maybe 40 contemporary user with all the level of cache, it was pretty hard to maintain a good level of performance, especially with Redis and the backend with the Flask layer. So I needed to move out at least the backend, and I went on the VPS for this reason. But I also move out the front-end side into Netlify with the Jamstack. So this helped me a lot to have a good performance back in the front end and also on the back end. Because after the first time that I used for beta testing and for personal use, it were like probably more than 20K page views per day, and more of course, more than hundreds of contemporary user. So no way that Raspberry could afford it, especially with that the 3B model. So for this, I changed it to the cloud environment, the simplest one, also for scaling reason, for of course availability, and for future, because 20K page views per day wasn't the highest page view recorded. The highest was probably around 100K, so pretty much high. And so that's why giving a sort of CDN on the backend side, and also move all the front end on the cloud via Netlify, save me a lot of time with troubleshooting. Why I'm not seeing the map? Why I got this amount of error log on my Redis and API layer. So let's see how it's working, the schema, how it's working all the map. Of course, there were a centralized Redis. This because I needed to find a good way to development and performance. So meanwhile, I was moving out all these architecture, all these instances. I needed also to develop and fix bugs that I found out, or my friends or others were finding out. So I needed to choose what was the perfect choice for me to have a balance between fixing bugs, give back a good data and good result. So this was the best thing that I could afford. Of course, with all these instances, 4 instances, I needed to have a kind of API rotation on the front-end side, just to check that maybe if a node was going down, I can give a response, a correct response to the end user by switching the API and also for balancing the traffic. OVH on the VPS doesn't have a load balancing service. You need to pay more for have the load balancer. So I needed to find out a way to make it on my own. Of course, I did also some performance check for especially working on the web server with Movigi and also with the Flask by adding multi-threading and cache layer for a better performance. And for this kind of architecture, making a good cache layer save a lot of time in performance, but also in during the development because you don't need to go crazy on how I need to optimize this service, I need to optimize these endpoints, but I can't do with those amount of data or those amount of traffic by yourself. So it's a good way to solve this kind of problem, the performance issue, and also the availability issue, putting a lot of cache layer into the web server and the API layer. Talking about API and Redis, finally we are. I put some snippet, but I prefer to redirect you for the coding experience to the repository where you can find out all the API, all the Movigi configuration, and also if you are interested into the front end part, you can find out also the front end side. So I got few endpoints for G-coding, so I can get back the G-coding data based on the Google API and the Here API. That is it's a Microsoft solution for against Google API to get the G-coding data. I put also some endpoint for feedback and logging, error logging, user logging, and feedback for having a real feedback from the user, and to put also the data that the user was giving into the application with the right amount of time of the line and in which place it was the line. Of course, there were also the main endpoint, that is the get waiting times endpoint to get the estimated waiting time for a place. That could be an address, could be a place, a name place, or just a mark on the map. And on the snippet, you can find out the multi-threading managed by Movigi on the Python. I got a lot of threading, but maybe 400 is not the right. It's the right number. Maybe it was a few less, way few less. But yeah. Movigi allowed me to do multi-threading, and also these improve by a lot the performance from the API layer. Because also with Redis as a database for collecting all the data that I was using and retrieving from the user and from the scraping script, I needed a good way to deliver those data. And with such amount of traffic, the only way that I could achieve was multi-threading the API layer. Talking about Redis, Redis really saved this project. Also Python saved this project for development speed, but Redis saved more because it's a really good database. If you if you don't know it, please have a look to it, because it really good, not just for caching but also for delivering some data. And for the geo data that I needed to deliver, collect, and manage, was the right choice to go with. In this snippet, you can find out some data that I needed to filter, to do a query from the map, from a search in the search bar with the place name or the place address, or just by moving the map and reloading and refreshing all the markers that were on the map. And this was accomplished by some Redis operator, geospatial operator, such as geoadd, georadius, and geodelete, that I needed to use to search, to add, and to delete a point, a mark on the map. And by storing those data, the good advantage was also, apart from the performance, was that you could also add in another database, in another Redis database, also the data that was associated with that place. And you can also have a distance filter. So if this place was maybe too crowded, you could give a solution to the end user to have a look to the other places that maybe just in about 10 minutes from there, in about a distance of 10 kilometers or 15 kilometers. It was just a filter that I needed to put on the query on the layer, and also on the front end side. Redis also saved me on this project, because except for a little thing maybe at the beginning where you needed to manage and to balance all the configuration to work to make Redis work really great. It was really easy to maintain, really easy to see how the data were working, and maybe drop some data, some database that were not that much used. So it was pretty good to develop the project with, of course, Python and Raspberry at the beginning, but also going into the cloud. It was an easy passage from replicate everything from Raspberry in a monolithic way, in a distributed way, into the cloud environment on OVH via Redis, of course, at centralized Redis, but also with all the other API layers and API instances. So let's find out how much does it cost at the end of the day. So from Raspberry to cloud, of course, I already had a Raspberry Pi, so the cost, it was null. But back in 2020, I think that the cost would be around $30 or 30 euros for buy a Raspberry Pi, the 3B model. But I used my the one that I already had, so and the cost was zero. I also used my personal domain, that was thejoin.tech, just creating a subdomain, just because it's not for the project was not for commercial use, or just for helping others and helping me at the beginning. So I just used a subdomain into my personal domain, and just use the port forwarding, the DNS, the dynamic DNS for deliver into the public and to my friends. In the average, I spent about $25 per month for the cloud usage with the all VPS of OVH and DigitalOcean. So the total is around $75 for 3 months of usage, because the project was online from April to June, maybe late June of 2020. So it's not a really high price for maintaining a project that delivered a lot of traffic. Speaking about traffic, that's why I spent just 25 per month, because the inbound and the outbound traffic was for free if you get low bandwidth usage, and the limit was to 10 gigabyte of per month. So it wasn't a real issue. By delivering really good data from the API layer, and just be with low traffic. I mean, traffic fares are pretty good, and they are pretty high for this kind of project, because you don't need to pass a lot of data through your APIs. For this project, they were just JSON collection and nothing too much heavy for the traffic. So in the end, I also used the cloud environment for the front end, and Netlify is free to use, also with the traffic inbound for maybe 2 gigabytes, probably for a month. So it wasn't an issue even there, because the front end was about maybe kilobytes of bandwidth. And it allowed me to satisfy more than 1 million of users and more than 2 million of sessions into the application in 3 months of the project life. And also with more than 1,000 contemporary users. And those are really high expectative from a little project that started from a personal use, using with Raspberry Pi, that the maximum contemporary user that could afford was around 40 maybe. And it's really a big deal for the amount of money that you put into, and also for the benefits that all the community across the world took it from the project. At least I hope that they get it saved to the local store or pharmacy. So in conclusion, I'm really pleased to have the chance of helping people from all the globe, from US to Brazil, in Italy, also in the East Europe, and few in the Australia. So I'm really glad to did the project, and that it served a lot of people. And also thanks to the open source, because all the things that I used, they were open source. Flask is open source, Python. Also the JavaScript part, I used a lot of open source library, such as Culp and others. And also because of open source, you can find out the code that I have written back in 2020. And also big thumbs up to Daniel Defoe, that helped me a lot at the beginning for make the map accessible to all the user with the WebVM, and also with a touch of design, because as a programmer, my design wasn't that good. It's working perfect, fine. The design is done. So Daniel gave me a lot of help into with collaborating with the whole pull requests about the design and the UI and UX. So big thumbs up to the open source and to Daniel. And well, thanks to my favorite beta tester, my friend and my family first, because of course, it was a really good chance to be outside and be safe more than just going outside in a random time and stay in the line for, I don't know, 2 hours maybe, and it's a real fact. So maybe half an hour is better than 2 hours in the freezing outside. And so, yeah, the code is still available on the GitHub. Of course, the website is now offline. Maybe you can visit on the repository because there is a link, but it's not working. The backend is not online anymore. So yeah, stay safe and do the bugs if you can. And so thank you.
Hey, Mickey, thank you. And very nice thank you screen as well. Never saw that.
Yeah, thank you.
Very cool. Okay, very interesting. Also, thanks for this contribution. Let me see if we have some questions. Yes, we do. Lucas has one. He's asking, have you analyzed or seen a correlation between usage of the map and actual pandemic situation in the corresponding location?
Yeah, at the beginning, in April, there was a strong correlation with the expanse of the virus into the region of the globe. It's beginning from Europe, from Italy, and then the first extra user that were not my family or my friends were coming from the European country, such as England or France. And then the next probably 10 days, the traffic changed drastically from Europe to the Americas. So Canada and US, basically.
Okay, so if you would filter on Google Maps, let's say by country, by geographical location, and you would basically overlay the, let's say, infections per day per region, then maybe you could see some similarities, right?
Yeah,
that's quite interesting. Good, thank you. Then Heinrich is asking, from a technical point of view, I assume, what would you do differently with the knowledge of today in this project?
Well, a lot, because I think that I rushed a lot during the development of the project. Not in the front end side, but in the back end, I just put a lot of effort in delivering the data that I was collecting, but not in the way I was delivering. So the caching layer, it was just a workaround to serve the data to the end user. But of course, I will optimize my code with some algorithm to deliver in other ways, not just caching, but also the Redis side. Probably I will change now with some knowledge, with more knowledge. I will change something. Yeah, for sure.
Yeah. Would you exchange any of the tools that you have used?
Well, probably not, because I think they were a good choice at the time, and also now they are a good choice, especially beginning with the Raspberry Pi. It's kind of testing out in a real environment how the performance can look, and how your API layer and the web server can maybe manage all the traffic inbound.
Okay, thank you. Felix is asking, do you plan to use the project for other use cases in the future, or the learnings from it?
For sure, learning from there, for sure. It's been a very, how can I say, challenging project for me. Because started from nothing, and it went with a lot of people that was like, I need some help. Okay. So for sure learning. Probably I will not use the project for other use. I hope, because
Yeah.
it will mean that another virus join the party, and I hope that it won't
But
happen.
could you imagine maybe something that is not related to pandemics, but let's say to use it for something different?
During
Like, for example, analyzing waiting times in front of Apple stores, resellers, when an iPhone comes out or something.
During the development, I was thinking about it, but then in late 2020, Google released a new API that is doing the thing that I was thinking. So collecting the data from, I guess, the Gmaps application, from the devices that are that have the geolocation permission, and just showing the data into the Gmaps application. So maybe for, I don't know, maybe for local, such as conferences, maybe it's great for delivering the people in the right amount to the stands or to the stage, maybe.
Okay, that's cool. Then maybe a personal question from my side. Like, when you did this project, what do you think? I mean, you've talked a lot about technical aspects of the projects, but why do you think the project went viral?
Well, actually, I don't know. Probably because as it was my necessities to go outside less time possible, also for my dear and for my family. Probably there was these needs from the people that was encountering the same situation that everyone was in the same situation. So probably it was because of this, and also because probably with social, if I discover something and I'm like messaging you that, hey, take a look at this map that I found out that is really working and is giving me the time to my local store. Probably you're gonna have a look and do the same with our other friends and other friends and put it on the social. So probably it was an escalation.
And it's really amazing with such a project, because obviously, in order for using this, that it makes sense for you, other people already need to use it, because otherwise you don't have the data and so on. So that's quite interesting. So maybe I would have a look again, like in how this all went viral, and with all of this word of mouth and so on, because this could be some interesting findings for you as well.
Yeah, it's really interesting. Also, by having a look of the data from the beginning to the end of the project, and you can see clearly the curve was more steep in the beginning, and then it shaped a little bit at the end. Probably because it was related, of course, with the pandemic curve. But yeah, it's really interesting in a social media terms.
Yeah, and in terms of regions, like I suppose it started like in Italy or local in your place, and what were the next bigger regions that basically got adoption there?
Yeah, chronologically, it started with Italy, then with France, England, and Eastern countries, like a little bit of Russia, Romanian, Polonian, and Germany. And then it went to the other side of the ocean with Canada, Brazil, and USA.
Oh, that's cool. That's some nice findings. I mean, you have now done this project. You also actively speak at conferences. I have another question from my side, and this is: did you make through this project like any interesting connections in your network? Did you get some job offers? Did it help you in your career, or how do you see that?
Well, of course, it helped me a lot of reaching new people, local and virtual, and yeah, it happened one time that one company searched me on the internet and discovered that I did this math and found me out to with an email to offer me a job. But I was already I was quite okay with my previous job back in 2020. So I just refused the offer, but we keeping in touch because they were doing, the company were doing some open source project that I was looking. So we keep in touch also with other people, with Daniel, for example, that helped me a lot on the front end side of the project. It was from Canada, for example. So of course, the project gave me the opportunity, the chance to collect new people into my network, but also to show to the network or to the others that I made a map that is working from Raspberry and others. So yeah.
That's cool. That's cool. So I'm sure you didn't maybe imagine in the beginning that it will turn out like that, but it's a really cool story. And yeah, I think we also don't have any more questions. So therefore, I would say, Nikki, it was a real pleasure to have you today here. So thanks for taking the time and joining us and answering all of the questions. I hope to see you soon again at some with some other talks maybe. Let's see what's going to be your next projects. And yeah, with that said, thanks for being here and bye.
Thank you too. Bye.
Bye. Okay, this was it with the Python Day, but that's not it for this year. We have next week another WeAreDevelopers live event. It's the Security Day, so stay tuned for that one. And RSVP if you didn't do so already. And also don't forget the WeAreDevelopers World Congress is happening in person in June 2022. Very excited for that. If you don't have ensured your tickets already, then yeah, take use of the super early bird tickets rate right now. And with that said, have a nice evening and have a nice rest of the day here from Vienna. See you next week again. Bye.
Everything is being influenced by code written by developers.
At some point, you're going to wake up and say, what the hell am I doing?
It's hard to believe. It's the largest group I've ever been in front of, I think.
We develop the future.